Critical environments, including data centers, hospitals, air traffic control, government installations, and major research projects, require high-quality, continuous power. IEM Power Systems' fully integrated Rotabloc RBT solutions efficiently deliver dependable power to all these applications and more. This simplified schematic shows the design of a single RBT UPS system protecting a critical load. Note that the genset is separate and usually located remotely from the RUPS, and essential short-break loads can be included in the system as required. The Rotoblock RBT is the basic building block of the IEM Power Systems critical power solution. It comprises the Rotoblock Energy Storage Unit, or ESU, the control and variable speed cabinets, and the power cabinet, including breakers D1, D2, and D3, and the UPS choke. This presentation will look at each of these in sequence before detailing the modes of operation and outlining the key features and benefits of the IEM Power Systems critical power solution. The Rotoblock comprises a patented high-efficiency energy storage unit, the accumulator, and a brushless, low-loss, low-impedance, synchronous machine, the alternator. The flexible SAE coupling connects the ESU and alternator shafts. The Rotoblock itself sits on a rigid steel-based frame with vibration isolation feet. The Rotoblock stores energy efficiently in a rotating steel drum. The amount stored varies from 7.2 megajoules to 16 megajoules, providing a range of outputs from 400 kVA, 320 kilowatts, to 2000 kVA, 1600 kilowatts. The forged steel drum provides the Rotoblock with its main energy storage for use during longer interruptions. It is simple, reliable, and highly recyclable. Inside the drum, robust components allow the energy stored to be transferred to the alternator shaft when required. The Rotoblock uses a magnetic rather than mechanical coupling, reducing wear, increasing reliability, and minimizing maintenance. The flywheel, essentially part of the shaft, helps maintain power frequency during short interruptions at the input. The patented pony motor is used to manage the speed of the drum. In conjunction with the VSD, it maintains optimal energy storage for the system. The exciter facilitates the frictionless transfer of stored energy to the shaft during interruptions to mains power. The coupled shaft increases maintainability and prevents whole machine issues. In normal operation, in a 60 Hz system, the shaft turns at 1800 RPM. With the maximum speed of the storage drum being 3000 RPM, the maximum relative speed is only 1200 RPM, low for a rotary UPS. The Rotoblock's low-speed shaft and bearings, combined with continuous bearing lubrication, maximizes reliability, reduces maintenance, and extends replacement cycles. IEM Power Systems provides a full 8-year bearing replacement warranty. Power and control cabinets are supplied with the Rotoblock and can also be integrated into the full switchgear lineup. The IEM Power Systems RBT is defined in this diagram. The Rotoblock RBT typically employs 3 cabinets to house the controls, variable speed drive, and LV power hardware. IEM Power Systems are experts in providing power solutions up to 38 kV to meet the requirements of your facility. The standard Rotoblock power cabinet contains power circuit breakers, choke, power buses, current transformers, and the VSD. The Rotoblock control cabinet contains a touchscreen HMI, power metering, mini circuit breakers, backup auxiliary power supply, and the main PLC. The standard LV cabinets have a small footprint and can be readily configured to your exact specification. Note the compact footprint of the Rotoblock RBT with its standard power and control cabinets. Modes of operation. The IEM Power System is designed to work as part of a fully integrated power solution. This is an IEM Power Systems UPS module. The diagram shows the main components and identifies key breakers D1, D2, D3, DM, and DG. There are 4 main modes of operation: bypass, UPS startup, normal power conditioning, and mains failure. We look at each in order. Bypass mode. Bypass mode isolates the Rotobloc from the facility's power system. In this mode, the UPS can be safely maintained while the load is supplied by the utility or genset via breaker D3. RUPS Startup. The Rotobloc starting sequence begins in bypass mode. The Rotabloc's pony motor is energized with AC power provided via the VSD. The main drum is accelerated to the required speed. When the drum is ready, the system injects current into the exciter, which is fed to the rotor coils. The resulting magnetic field creates a frictionless bond between the rotor and drum, gently accelerating the shaft up to its operating speed. When the shaft reaches its operating speed, the synchronous machine is excited and the alternator is energized and generating voltage. With D1 and D2 open, the Rotobloc remains isolated from the facility's power system. The Rotobloc is then synchronized to the frequency of the incoming utility, and breaker D1 is closed. The UPS is now grid-tied, but the load is still supplied via the bypass at this stage. The storage drum is now accelerated until it reaches its operating speed. This is determined by the requirement of the load that it will protect. The VSD regulates the stored energy by controlling the speed of the drum to match the requirements of the critical load. This unique approach further improves the efficiency and reliability of the Rotabloc UPS system. When the required energy is stored in the accumulator, D2 closes as D3 opens. The critical loads are now protected by the UPS. The system is now in normal power conditioning mode. Normal mode. In normal mode, the critical load is fully protected by the Rotobloc system. Utility power is present and all power is conditioned as it flows to the critical load via the UPS choke and alternator. The Rotobloc maintains the voltage at the load by supplying reactive power when required. Power conditioning represents 99% of the work done by the UPS. Utility failure. During the first 60 to 80 milliseconds of utility failure, the Rotabloc's synchronous machine feeds the critical load as it does during any short transient fault as part of normal voltage conditioning. This energy is provided by inertia of the flywheel and the shaft. The loads do not experience any power loss or variation in the quality of power. When a sustained mains failure of over 80 milliseconds is detected, the UPS system opens D1 to isolate the load from the grid. If mains power returns, the UPS will resynchronize with it across D1 before the grid is allowed to resume supplying the load. Sustained mains failure. During sustained mains failure, the energy transfer is initiated by an injection of DC current into the exciter of the accumulator. The DC current is injected to maintain the shaft speed so that the electrical frequency at the alternator output never falls below 59.5 Hz. The magnetic coupling of drum and rotor transfers the energy from the drum without mechanical engagement. This patented design provides frictionless energy transfer to supply power to the critical loads while the diesel starts. After holding the system for 1 second, the control system sends run genset and stay on genset signals. After about 6 seconds, the diesel genset is ready to accept load. The changeover switch operates to open breaker DM and close DG. The control system monitors the phase angle and frequency of the load and the genset, managing the synchronization across breaker D1. As soon as the synchronization conditions are met, D1 closes and the load is progressively transferred to the diesel genset until it supplies the full critical load. During the transfer of the load to the genset, the storage drum gradually slows down until it is near parity with the shaft speed. Running the genset. During sustained outages, the genset supplies all critical loads until a stable utility has returned. Surplus genset power is used to recharge the accumulator. The genset can be sized to pick up the essential loads after a short break. Return to restored utility supply. The recharged UPS controls the transfer back to mains operating using either an open or closed transition, depending on the requirements of the local utility provider. During a closed transition, The ATS controller manages the uninterrupted transfer of power from the genset to the mains. The Rotoblock and diesel remain ready to protect the load in the case of repeated grid failure. During an open transition, the Rotoblock supports the critical load for the 2 seconds required for the transfer back to the utility. The diesel remains ready to protect the load should mains fail again. First, DG and D1 open, and the load is carried by the Rotoblock without interruption. After a programmed interval, DM closes and the UPS synchronizes with the grid across D1. The genset is disconnected but kept running until the accumulator is recharged. If mains power was lost again at this stage, the load can be quickly and seamlessly transferred back to the genset. Once the system has returned to utility power and the drum is recharged fully, the system is in normal power conditioning mode. With the mains restored and the Rotoblock fully charged, the diesel is allowed to enter cool-down mode. This graph summarizes the mains failure and restore process. Features and benefits of IEM Power Systems UPS. High short-circuit power for fast fault-clearing capacity. High efficiency, typically 96% at full load. Dynamic autonomy control allows over 90% efficiency at a quarter load. Air conditioning is not required, improving PUE. Easy parallel operation with distributed control, eliminating single points of failure. And modular, scalable, and highly resilient. Low maintenance. Simple, light-touch maintenance routine. No UPS downtime required for lubrication. Standard components and spare parts. 8-year bearing replacement warranty. Features and benefits versus traditional drums. Having a separate diesel engine genset allows independent maintenance of genset and UPS. Compatibility with most gensets, even existing installations. Flexibility of genset power sizing to match critical and short break loads. Physical separation of diesel engine genset allows the UPS to be close to the critical load. Because the genset can be placed remotely, exhaust gas, fuel, and noise are removed. Programmable ride-through protection of up to 1 second without genset start improves genset lifetime and reduces genset maintenance. Additionally, fewer genset starts reduce fuel consumption and minimize the system's environmental impact. Independent redundancy of UPS and genset also creates double redundancy, reducing the risk of system failure. Further, the genset can be used as continuous power source, and the genset can be tested on load without risk to your facility. Summary of benefits. Rotoblock UPS is purely a simple electromagnetic system without battery banks or inverters and with no power semiconductors. Rotoblock does not require a vacuum, gas, or magnetic bearings. Our system has no mechanical coupling with the diesel engine and employs low-speed bearings for the greatest reliability. The Rotoblock UPS provides voltage conditioning and ride-through protection against slow voltage variations, voltage sags and surges, voltage distortion, harmonics, flicker, microcuts, and shortcuts up to 1 second, adjustable. The RBT system also provides load conditioning with power factor compensation, harmonic current filtering, and rebalancing of phase currents. For further information, please visit iemps.com or email the Critical Power team at info@iemps.com.